Hello, my name is Lance Hunt, and my project takes a look at solutions to solving the problem of software access in education. Remote access to technology has been around for years, and not a new concept, but virtualization has enabled it to be efficiently implemented and scaled. With the current virtualization technologies, education can benefit from its cost-saving architectures while providing access to software resources remotely at any time from anywhere. I will discuss 3 areas of virtualization that stands out as an innovative platform for helping education extend its technology beyond the traditional classroom walls. Let's take a moment to understand the problem. Imagine a class is getting ready to start an assignment and it requires a software application like physics program that models, simulates, and explores a wide variety of physics concepts. Now, before the students start using the software is usually pre-installed and configured on the workstations. This usually involves IT staff to deploy the application to the lab using sophisticated desktop management tools. When the software is ready to use, you are now faced with the limited amount of time the class meets to do the assignment. The classroom is shared with other classes, and it makes it difficult for students that need extra time to access the computers. Perhaps this physics application has strict licensing, and it must be installed on institutions' computers only, meaning they cannot hand the software out to the students to take home and install on their personal devices. Now, what if we did have a piece of software that students could install on their own device? Other problems may occur due to the wide range of devices students might have, and introduce problems like operating system inconsistencies or versions of Java if the application requires it. So the challenges we face with software in education is that it has limited availability. It can require high maintenance to deploy, update, and scale, and sometimes licensing restrictions. What if we could level the playing field to where all students could log in to the same environment, run software, and the results are the same? One student could have a Mac, one could have a PC, and another one have an iPad, but it no longer matters since they are viewing a screen of the remote system. Could the idea of remote access save time it takes we spend on these issues? And that's where my project picks up to examine how it is possible to overcome these challenges with different virtualization platforms. Cloud computing is so heavily used today that we sometimes forget what it means. You can think of it as centralizing hardware like servers, workstations, and storage at a data center somewhere with a variety of services that may run on top of it. Most people think of clouds as only being hosted by big companies like Google, Microsoft, or Dropbox, but organizations can centralize their hardware too and offer the same benefits to their users, such as students and faculty in education. When these resources are centralized, virtualization technology provides you with a robust layer that efficiently utilizes the hardware to its full potential and scales as demand grows. Remote access in general sense means that students are using their personal devices to view and interact with remote systems, and so that they feel as if they were on campus. Remote protocols are the conduit to which a screen of the remote system is presented on their end device. Some protocols, such as RDP, PC over IP, SSH, VNC, are dedicated to providing this experience. Lots of studies have been done on the overall usefulness of each protocol and tested, and how different applications run remotely by measuring resource usage, bandwidth consumption. So I didn't study the protocols in depth, but I did include references to these studies in my paper. Selecting the right remote protocol is important since the end goal is to have the same experience as if you were sitting in front of the same piece of physical hardware. Virtual desktop technology has been around and has been around the longest and has matured with lots of management suites that help provision and proctor access to the virtual desktops. VMware, Citrix, and Microsoft lead in this space. At a high level, you can think of desktop virtualization as running numerous instances of desktops on enterprise-grade level servers in a data center. Picture taking a lab of 20 or so computers in a classroom and being able to run all of the desktops on one server. The approach to implementing virtual desktops is easy to understand since you are taking a desktop with pre-installed software and converting it to a virtual machine. Once virtualized, those desktops can be cloned, remotely accessed using remote protocols from any device from any location. So I created a quick demo here of a virtual desktop that I'm accessing from my home PC. I'm launching a couple of applications, ArcMap, Interactive Physics, and MATLAB. These are all pretty advanced applications, very complicated to install, but I'm able to access them and work on my homework and save it at any time from anywhere. As mentioned earlier, selecting the right remote protocol for access is important. As you can see in my demo, the applications that I was using were very responsive and there was no lag between my interaction to the remote system. Other important consideration is operating system and application licensing. You'll need to review Microsoft licensing requirements to make sure that you're compliant in offering your organization's Microsoft Windows and Office remotely. When you look at the persistence of virtual desktops, it basically means resetting the desktop after each session, so it guarantees a state that would be the same for the next student that logs in. So after the desktop I was showing, when I log out, that desktop resets itself to a state before I logged in. When talking about pools, you can think of a pool of desktops, let's say 100, that are available at a first-come, first-served model. You can have thousands of students that can log in, but only a limited number of seats are available. But since students can access the environment at any time, other factors like their work schedules can cause logins from different times of the day. So monitoring login trends will help gauge this, and the pool size can be scaled up as more students log in at the same time. I studied a year's worth of login logs to a project called Virtual Lab at the University of North Georgia, which offers virtual desktops remotely to students and faculty. I was able to determine the popular times of the day that students most logged in, which looks like it peaks around noon. Take note that there was even some students that were logging in between 2 and 5 a.m. Also, online students could be in different time zones, so it's critical to keep access to these desktops at all hours of the day during the semester. One other thing that I found interesting was the days of the week where logins were most common. This data shows that it may be a good day to perform system maintenance on Sundays. I was also able to take the login data of the students and compare it with their declared major to sort of illustrate that virtual desktops were actually more popular for business and biology majors rather than, let's say, computer science or even other technical focused majors. The goal here is to show the wide range of subjects that all students can share the same virtualization platform. I've worked with virtual desktops for a while now and have been on some of the coolest projects. I've worked on, well, one of the ones that I worked on was implementing virtual desktop access to teach GIS for local area middle school and high school students. I'm sharing this to demonstrate that using this technology can also be used for users outside of your organization in collaborative projects. As you can see, the computers in the school that we went into were somewhat outdated and underpowered. Just look at the CRT monitors on the far left image. But the students were able to remote in, connect to virtual desktops, and build some amazing maps using ArcGIS software. Virtualization has opened up the door to so many different solutions in education. Previously, we looked at virtual desktops that can be implemented at an institution. But what about institutions that don't have the resources to implement the underlying technology? That's where infrastructure and platform as a service allow schools to rent data centers hosted by cloud providers like Amazon, Microsoft, and Rackspace. With a swipe of a credit card, virtual machines can be powered on in a data center managed by the provider, and you're just responsible for the virtual machine's operating system and applications. I want to showcase a short video of Virginia Tech's use of infrastructure as a service to where they're accelerating cancer research that sequences genomes now in a day rather than when it took weeks. Previously, they would spend millions of dollars to build large, high-performance compute clusters, But in this particular case, they use Microsoft Azure to access their research computing nodes at a smaller fraction of the cost it took to run locally. Even though the virtual environments are hosted at a provider's data center, the same security concerns as running it at the institution applies. Ian Foster outlined in his research some security design considerations in virtual environments that I listed here. And there are a couple I want to highlight, such as regulatory compliance, data location, and recovery. Workstations on campus still have to be managed and secured to limit the risk of system compromises, so using the same tools, such as antivirus and auditing, should be used in virtual environments, keeping a nice consistent set of tools to manage. The data inside or access from virtual environments should be considered when it comes to regulatory compliance. In virtualized environments, the physical hardware is shared with other systems that could be required to meet FERPA or PCI compliance. You'll need to examine the controls in place that continue to isolate and separate these systems and use privileged access when needed. In the case of virtual desktops, persistence policies can be enforced, so when a student logs off their session, the virtual desktop resets itself to its original known state, deleting any new data files stored locally. It becomes critical for students to understand that they will be assigned a new desktop each time and that they must always save their work to their personal network folder at all times. A more recent virtualization technology called containers implements a layer of abstraction between the operating system and applications, allowing multiple instances of an application to be separated and ran independent of each other. Containers are the least mature out of all the virtualization platforms and not as turnkey to implement for organizations. But this also presents the opportunity in education to explore and shape solutions built on container technology so it can be documented and widely shared. While the first wave of container virtualization solutions in education targets computer science, it also has the potential to provide even greater reach in other subjects. It will be exciting to see the new possibilities as it becomes more developed. Upon my research of containers in education, I found one example at a university in Turkey where the system they developed, called PAGS, a programming assignment grading system, which this system uses Docker, that is also a leader in container technology, which allows students to submit their code, see live results, and it also allows dialogue between the teacher and the student through interactive feedback response windows. So instead of having the students run their code in independent virtual machines, they isolate each student's code in containers, and the students can interact with the remote system through a web browser. During my research, I came across Mladen Volk's work that outlined cloud computing issues and implementations. He talks about all of the different components of an implementation of virtual cloud environments that involve system designers, students, faculty, and the system itself. He discusses what a successful cloud in education should look like. I used this criteria to apply a maturity level of each virtualization technology talked about in my paper to give an educational organization a rubric to select the best platform for their goals. Virtual Desktop scored the highest since it has been around the longest and with the most matured set of management tools for organizations. Virtual desktops also have plenty of use cases in education that can be found. Infrastructure and platform as a service is a viable option for organizations that may not have the technical staff or resources to implement virtual desktops, and it may just be too expensive to stand up the hardware in-house. Lots of cloud providers are available to host virtualization for education so they can be more focused on building or cloning the virtual images. Container scored the lowest out of all the solutions since it hasn't been out as long. But over time, in its startup development effort, this will continue to mature and make it easier for organizations to adopt in education as more use cases are discovered. I hope I was able to give you some insight into how technology and software resources can be more efficiently accessed in education by utilizing virtualization solutions. Each solution has a distinct set of features that can be used in education in some form. Combining the solutions would accelerate access to the software needed to fulfill the pedagogical learning assignments of a course. I also hope that the various virtualization platforms would continue to be studied and evaluated in education, thus maturing its use and becoming a pillar in how technology can be accessed. Thank you for watching my presentation.